One last type of problem that we are going to work with parabolas is the same process as that we were doing before, but in example 3, we are going to find the focus and directrix of a parabola that has some other stuff going on. So we're going to find the focus and the directrix of y equals x squared plus 8x plus 18. Now in this equation, we don't just have that y equals some number times x squared. We have this other stuff going on here. Our equation is in standard form, which means my vertex isn't necessarily at the origin. It's not at that point 0, 0. What we have to do here is we need to complete the square. So that we can figure out where our vertex is in this parabola and also what that focal length is. All right, so how do we complete the square? Completing the square, we take our b value, our coefficient of the x term, divide it by 2, and square it. Okay, so I'll make this note here. To complete the square, it's b divided by 2 squared. Well, b divided by 2 squared, 8 divided by 2 is 4, squared is 16. We need this to be 16. So in order to get this to be 16, we have to subtract 2 from each side. Okay, so y minus 2, I subtracted the 2 over here, equals x squared plus 8x plus 16. Again, I subtracted the 2. And the reason that we complete the square is because now I can factor this as something squared. X squared plus 8x plus 16 is really all x plus 4 squared. Add 2 to each side, and all of a sudden our equation of this parabola is in vertex form. Okay, so this tells me my vertex, if you think of transformations, was translated left 4 and up 2. My vertex is at negative 4, 2. Once we figure that out, let's start off by kind of drawing our picture here. I know my vertex is negative 4, 2. It's right here. And since my equation is y equals, I know my parabola has to be vertical. I don't have a negative, so we open up. Now to figure out that focal length, we have to look at the coefficient that's in front of the x squared. The 4, the 2, that's all just transformations. I have to look here. Well, and there really is, even though there's not a number written, remember there really is a 1 that's there. Okay. So in this case, that a value equals 1, so 1 over 4p has to equal 1. Okay, multiply both sides by 4p. Divide both sides by 4. We get p is 1/4. Okay. Well, that means our distance from our vertex to our focus is 1/4. And that distance from our vertex to our directrix is 1/4. So I'm going to rewrite here that our vertex is at negative 4, 2. Our focus is again 1/4 above that. So negative 4, 2 1/4. Okay, I'm going to be okay if you leave your answer like this as 2 1/4. You also, if you just kind of want to get some extra practice with fractions, to change from a mixed number to an improper fraction. That's where we take the denominator times the number in front plus the number on top. 4 times 2 is 8 plus 1 is 9/4. That's the same thing. And then the directrix is a fourth below a fourth below our vertex. So a fourth less than 2. So horizontal line, y equals 1 3/4. Or if you, again, want to get some practice with your fractions, that would be y equals 7/4. Either way, I'd really be okay with your answer here. But really the main trick here is that we have to complete the square to figure out where our vertex is before we find our focus in directrix.